Today, we're going to be looking at integer rules, and we're also going to just do a really quick rundown of what we did in class the previous session. We started off our lesson by looking at the objective of being able to establish basic vocab, math operations vocab. We also talked about just a little bit of a preview of converting math into English and English into math. When we were talking about problems with integers, though, like our warm-up, many students mentioned that they were just feeling a little bit rusty and wanted some review over this, so that's what we're going to focus on today. But do keep in mind all of our vocabulary that we examined in class. This page is up on our website, okay, so our Google Classroom, make sure to check it out there. We did look at a geometric explanation for our exponent vocab, and that seemed to make a really huge difference for students. We also looked at the pitfalls of why some students may think that 2 to the 4th power is 8, when it is in fact not 8. That common misconception we discovered came from the introduction of different ways of representing multiplication around the same time that we introduced exponents. And with that common misconception, students think that if a number is next to another number and there's no plus or minus sign, it's automatically multiplication, which is not true. The 4 at the top here is a different size than the 2 as the base. And so you are multiplying, but it's not what you think. It's not 2 times 4. It's you have 4 sets of 4 number 2s that you're multiplying together. So 2 times 2 times 2 times 2 is 16. We talked about extra considerations in some of our class periods, not all of them. I do need you to make sure that you're aware of what it means to evaluate something. That's a crucial vocab word. You'll see that throughout your math career as well. We also talked about our word problem, and then we discussed some strategies as well. So drawing a picture, underlining, boxing information that you need, also scratching out information you don't need. That's always a good strategy. We skipped this question because we wanted to save a little bit of time and talk about words into math. So a little bit of our vocabulary. I did not do any lessons with the vocab yet, and the reason why, other than the word problem that we looked at together, because I want to give students a chance to be able to look at their vocab. So these turnaround words are words that students tend to struggle with. Quotient, per are 2 words that mean division that students struggle with. Product and of for multiplication, but of is one of those weird ones, okay? Because just because you see the word of doesn't necessarily mean that it's going to be multiplication in and of itself. It could be that it's unlocking the opportunity to use what are referred to as parenthesis words. So if I say twice the sum of something, or times the sum of, so it's opening up parentheses to allow me to put another expression inside of it. So we'll look at that on Monday. You also are really strong with your equals, so there's no need to worry about like that particular vocab. But here is the creme de la creme. So the purpose of the lesson are integer rules. And what I'm going to do is I'm going to insert a bunch of slides in here, or just work on one slide to show you a couple of problems, okay? So the first thing that students mention is addition. So same signs, we're going to add the 2 numbers and keep the sign the same. This is going to seem really basic, okay, in the beginning, because I am expecting you all to know this problem, and we're going to use it as a stepping stone, okay? So if I give you 3 plus 4, you're adding. 3 is positive, 4 is positive, so 3 plus 4 is 7, because the signs are the same, you add, and it's a positive 7. So your final answer is 7, you don't need the plus sign. Now, if I give you negative 3 plus negative 4, we're still adding, and notice how the signs are the same. So I'm going to add them together, and your answer is negative. Okay, so we have that taken care of. So that is done. Now, when we look at different signs, let's talk about that. So if I give you negative 3 plus 4, I'm still adding, but look at the signs now. One is negative and one is positive. So you're going to take the larger of the two and subtract them. And then look at your numbers again, 3 and 4. 4 is larger than 3, and 4 is positive. So I'm going to take the sign of the larger item, so that's why your answer is 1. Now if I flipped it, and let's say I had negative 4 plus 3, it's the same strategy, okay? So you would do the 4 minus 3 again to give you 1. But this time, your 4 is negative. It's larger. 4 is larger than 3, so it's a negative 1. Now, I'm looking at the absolute value of these items. I'm not saying that negative 4 is greater than a positive 3. I'm looking at the values without their signs. So I'm comparing a 4 to a 3. 4 is larger. The sign on 4 is negative. Therefore, your answer is going to be negative overall. I could also represent my answer like this. I could say 2 plus a negative 1. These are opposite signs. 2 is positive, 1 is negative, so I subtract. Now 2 is larger than 1, and 2 is positive, so it's a positive 1. So that's how you kind of look at those signs and analyze them. So that's what happens when we have different signs. Now we're going to talk about subtraction. Now some students like this idea of keep, change, change, and you could totally do that. But here's how I like to view it. If I have something like 4 minus 3, once again, we start off really easy and then we build. You can do it as a plus and minus. So plus and negative is the same thing as minus. The signs are opposite and we're adding. So 1 and then 4 is larger than 3, so it's positive 1. So nice, easy way to think about that. Another way you could think about these is like money. You have $4. You lose $3, you keep $1. Okay, so you're like, okay, this is easy for these examples, but what about something a little bit more challenging? So if I give you something like 2 minus 10, that's the same process. Change it to plus and negative. The signs are different, so you subtract. 10 minus 2 is 8. Now 10 is larger than 2, and 10 is negative. Therefore, your final answer is negative. All right, I've been putting positives for the first number, so let's check out what happens if it's a negative as the first. It's the same property. Plus and negative turns it into addition because they're both the same sign now. You can add them, keep the sign the same. 1 plus 12 is 13. Since they're both negative, your answer is negative 13. And that's it. Okay. There is one final concept that is not on that little walkthrough here, and that is what happens with double negatives. Well, I am glad you asked, because if I give you something like 3 minus negative 2, I want you to remember that that minus sign technically means opposite. So I want you to think of it this way. What's the opposite of a negative 2? The opposite of a negative is a positive. So your answer here is 5. With that rationale, another thing that you can do, when you have the double negative, you can extend the negative to turn it into a big old plus sign. So that's a little shortcut that you can do. Now, at this point, I did have students in class ask me about, well, what about signs for multiplication? So we're going to look at that right now. So signs for multiplication. This also works for division. Okay, so here's what happens. Our goal is to get to a plus sign. Okay, that right there is awesome. We love plus signs. They make us happy. When I'm multiplying a positive times a positive, that's a positive. Because there's nothing I can bundle together. Okay, but if I have a negative times a negative, think of it this way. This is 1 stick, and this is 2 sticks together. So if I bundle them together, the first one is the bottom piece. The second forms the top for a plus sign. Now, if I have a plus times a negative, okay, this right here is a full plus sign. Okay, so I'm good there. But then I have this leftover, so we put the leftover that we have hanging out. Same as negative times positive is negative. Okay, and those are our answers there. A negative needs another stick to make a plus sign, right? But that's already a plus sign. We can't combine anything, so we got the negative that's left over. So then I gave this really interesting question. What about all the signs? Let's say that I have a bunch of negatives. So let's say -1 times -5 times -7, etc. You get the idea. What is the final sign going to be? Well, let's throw in a negative on the end of there too, just to make it interesting. So we have all the negatives. These two bundle, form a plus sign. These two bundle, form a plus sign. These two bundle, form a plus sign. Oh, look, one left over. Your answer is going to be negative. So it doesn't matter what the numbers are, because we know that our final answer is going to wind up being negative when we analyze the signs. So here's a really cool way to remember it. Even number of negatives it's going to equal positive. So example being negative times negative times negative times negative is going to equal positive because I have an even number of negative signs. Now, if I have an odd number of negatives, it's going to equal an odd value. And so my example would be negative times negative times negative. That's going to equal a negative. And the reason for that is because these two are going to bundle, but then we have right here, one little one is left over. And that's it. We also played a game in class using Gimkit. It worked for all of the class periods except for the 6th period class that I have. I did post that as an extra credit homework assignment. So 6th period, you can work on that if you'd like. We will start on Monday by going over our vocab words, and we're going to talk about translating a verbal expression. Okay, so we'll look at these problems. But your #1 job this weekend, study the words into math. This paper is going to make it so much easier for you if you know your vocab. If you don't, you're going to continue having difficulties in math. There's no way around that, unfortunately. I did post a drag and drop activity on Google Classroom, so be sure to check that out. I hope you guys have a nice weekend, and I will talk to you soon.